Windows Operating Systems Part 2, Optimizing Windows. In this nugget, we begin by learning about the Windows tools you need to optimize Windows. Then we turn our attention to the steps you can follow to cause a sluggish Windows system to perform at its best, and how to manually remove software that does not uninstall using normal methods. Sounds like we're talking about a grain of wheat, but Windows has a shell and a kernel, and you need to understand what they are and how they work so you can solve problems with each. A shell is the portion of an operating system that relates to the user and to applications. The kernel is responsible for interacting with the hardware. Figure 4-1 shows how the shell and kernel relate to users, applications, and hardware. In addition, the figure shows a third component of an OS, the configuration data. For Windows, this data is primarily contained in the registry. The kernel or core of the operating system is responsible for interacting with hardware. Because the kernel operates in kernel mode, it has more power to communicate with the hardware devices that the shell has. Applications operating under the OS cannot get to hardware devices without the shell passing those requests to the kernel. This separation of tasks provides a more stable system and helps prevent a wayward application from destabilizing the whole system. The shell, on the other hand, provides tools such as Windows Explorer or the Windows Desktop as a way for the user to do such things as select music to burn to a CD or launch an application. For applications, the shell provides commands and procedures that applications can call on to do such things as print document, read from storage device, or even display a photograph on screen. The kernel has two main components, the HAL, or the hardware abstraction layer, which is the layer closest to the hardware, and second, the Executive Services Interface, which is a group of services that operate in kernel mode between the user mode subsystems and the HAL. Executive Services contained the NTOSKRNL program. This is a program file that manages memory, I/O devices, file systems, some securities, and other key components directly or by way of device drivers. When Windows is first installed, it builds the HAL based on the type of CPU installed. The HAL cannot be moved from one computer to another, which is one reason you cannot copy a Windows installation from one computer to another. When an application is first installed, its program files are normally stored on the hard drive. When the application is launched, the program is copied from the hard drive into the memory, and there is this thing called a process. A process is a program that is running under the authority of the shell, together with the system resources assigned to it. System resources might include other programs it has started and memory addresses to hold its data. When the process makes its request for resources, this request is made to the Win32 subsystem and is called a thread. A thread is a single task, such as the task of printing a file that the process requests from the kernel. Figure 4-2 shows two threads in action, which is possible because the process and Windows support multi-threading. Sometimes a process is called an instance, such as when you say to a user, open 2 instances of Internet Explorer. Technically, you are really saying to open 2 Internet Explorer processes. Now that you're familiar with the concepts of how Windows works, let's see how to use some tools that can help us manage Windows components and processes. Task Manager lets you view the application and processes running on your computer, as well as information about process and memory performance, network activity, and user activity. There are several ways to access Task Managers, and they are presented here in the current slide. The Process tab of Task Manager lists system services and other processes associated with applications, together with how much CPU time and memory the process uses. This information can help you determine which applications are slowing down your system. The Processes tab for Windows 7 Task Manager shows the process running under the current user. This screenshot can easily be taken immediately after a Windows installation and before any applications are installed. You can use the system configuration by file name. It is identified as msconfig.exe utility, which is commonly pronounced as msconfig, to find out what processes are launched at startup and to temporarily disable a process from loading. Using msconfig should be a temporary fix to disable a program or service from launching at startup, but it should not be considered a permanent fix. Once you've decided you want to make the change permanent, the user use other methods to permanently remove the process from Windows Startup. For example, you might uninstall a program, remove it from the startup folder, or use the services console to basically disable the service. The Services Console program file services.msc is used to control the Windows and third-party services installed on a system. To launch Services Console, type services.msc in the search box and then press enter. If the extended tab at the bottom of the window is not selected, click it. This tab gives a description of a selected service. When you click a service to select it and the description is missing, most likely the service is a third-party service put there by an installed application. To get more information about a service or stop or start a service, right-click its name and select Properties. Computer Management, otherwise known as COMP, MGMT.MSC, contains several tools that can be used to manage the local PC or other computers on the network. The window is called a console because it consolidates several Windows administrative tools. To use most of these tools, you must be logged on as administrator, although you can view certain settings in the computer management if you are logged on with lesser privileges. Microsoft Management Console, otherwise known as the MMC.exe, is a Windows utility that can be used to build your own customized console windows. In a console, these individual tools are called snap-ins. A console is saved in a file with a .msc file extension, and a snap-in in a console can itself be a console. To use all of the functions of MMC, you must be logged on as well as the administrator of the machine. Just about anything that happens in Windows is logged by Windows, and these logs can be viewed using the event viewer. The standalone program is eventvwr.msc. You can find events such as hardware or network failures, OS error messages, a device or service that has failed to start, or general protection faults. Event Viewer is a computer management console snap-in, and you can open it by using the computer management window by entering Event Viewer or eventviewer.msc in the search box, or simply by using the admin tool group in the control panel. Windows Task Scheduler can be set to launch a task or program at a future time, including at startup. When applications install, they might schedule tasks to check for and download their program updates. Task Scheduler store tasks in a file store in this folder, c:\windows/system32\tasks. To open Task Scheduler from the control panel, double-click Task Scheduler in the Admin Tools group. Alternately, you can click Start, All Programs, Accessories, System Tools, and Task Scheduler. The Task Scheduler window is shown here in Figure 4-30. Many actions such as installing application software or hardware can result in changes to the registry. These changes can create new keys, add new value to existing keys, and change existing values. For a few difficult problems, you might need to edit or remove a registry key. This part of the slide looks at how the registry is organized, which keys might hold entries causing problems, and how to back up and edit the registry using the registry editor or regedit.exe. Let's first look at how the registry is organized, and then you'll learn how to back it up and edit the registry. Windows builds the registry from the current hardware configuration and from information it takes from these files. There are 5 files stored under the c:\windows system32\config folder. These files are called hives, and they are named the SAM, Security, Software, System, and Default hives. Each hive is backed up with a log file and a backup file, which are also stored in the c:\windows system32config subfolder. For Windows 7, the c:\user's username ntuser.dat file holds the preferences and settings of the currently logged on user. After the registry is built in memory, it is organized into 5 high-level keys as identified by Figure 4-31. Each key can have subkeys, and subkeys can have more subkey and can be assigned one or more values. The way data is organized in the hive files is different from the way that is organized in the registry keys. Figure 4-32 shows the relationship between registry keys and hives. For example, in the figure, notice that the H key class's root key contains data that comes from the software hive, and this data is also stored in the larger H key local machine key. When you need to edit the registry, if possible, make the change from the Windows tool that is responsible for the key. For example, by using the Programs and Features window in Control Panel. If that doesn't work and you must edit the registry, always back up the registry before attempting to edit it. Changes made to the registry are implemented immediately. There is no undo feature in the registry editor, and no opportunity to change your mind once the edit is made. Here are the ways to back up the registry. Use System Protection to create a restore point. Back up a single registry entry key just before you edit the key. The Windows 7 tools for monitoring performance and optimizing resources that differ significantly from previous version of Windows include Windows 7 Performance Information and Tools window, Resource Monitor, Reliability Monitor, and Performance Monitor. These tools are covered next. The Performance Information and Tools window gives information to evaluate the performance of a system and to adjust Windows for best performance. Use one of the following methods to open the Performance Information and Tools window. 1. You can click Start, then right-click Computer, and then select Properties. In the System window, click Performance Information and Tools. In the Action Center, you can click View Performance Information. Windows 7 Resource Monitor or resmon.exe as a shortcut monitors performance of the processor, memory, hard drive, and network. As you learned earlier in the chapter, Task Manager reports some of this information already. To access Resource Monitor, use one of these methods. 1. You can go to the Task Manager and then click Resource Monitor on the Performance tab. Another way is in the Performance Information and Tools window, click Advanced Tools and then click Open Resource Monitor. Another way is going to the Computer Management window in the System Tools, Performance group, click Monitoring Tools, More Actions, and then go to and click Resource. The easiest way to find out if a system would benefit from a memory upgrade, that is, adding more memory to the system, is to watch this memory bar as a user does her work. If you consistently see free memory disappear from this graph, the system would benefit from more installed memory. To best gauge the performance of a system, ask the user to watch the Resource Monitor throughout the workday and note what the monitor shows when the system is busiest. The Windows Reliability Monitor gives information about problems and errors that happen over time. Unless someone has cleared its history log, it reports problems since Windows was installed. To open the Reliability Monitor, open the Action Center, click the down arrow to open the Maintenance group, and then click View Reliability Monitor. The Reliability Monitor window is shown here in Figure 4-42. When you click an error in the column graph, the error and other events that happened the same day appear at the bottom of the window. Double-click one of these errors or events to see more information about it. Windows 7 Performance Monitor is a Microsoft Management Console snap-in that can track activity by hardware and software to measure performance. Whereas Resource Monitor monitors activities in real time, Performance Monitor can monitor in real time and can save collected data in logs for future use. Software developers might use this tool to evaluate how well their software is performing and to identify software and hardware bottlenecks. Performance Monitor offers hundreds of counters used to examine many aspects of the system related to performance. The Windows default setting is to show the percent processor time counter the first time you open the window. This counter appears as a red line in the graph and tracks activity of the processor. Going forward, you'll learn to search for problems affecting performance and to clean up the Windows startup process. These step-by-step procedures go beyond the routine maintenance tasks you learned in the previous chapter. Here, we are assuming Windows starts with no errors. If you are having trouble loading Windows, it's best to address the error first rather than to use these tools described here to improve performance. Let's look at the 10 steps you can take to improve Windows performance. It might seem pretty mundane, but the first thing you need to do to improve performance of a sluggish Windows system are the routine maintenance tasks that you learned in the previous chapter. These tasks are summarized here. For very critical Windows settings, make sure Windows updates are current. Do cleanup, do defrag, and check the hard drive. Make sure at least 15% of drive C is free. Uninstall software you no longer use or need. Use the Windows 7 Programs and Features window or the Add Remove Programs window to uninstall programs you no longer need. The most important step following routine maintenance to improve performance is to verify that startup programs are kept to a minimum. Before cleaning Windows Startup, you can use Safe Mode to set a benchmark for the time it takes to start Windows when only the bare minimum of programs are launched. To speed up startup, search for unnecessary startup programs you can eliminate. Tools that can help are the msconfig.exe, otherwise known as the System Configuration Tool, startup folders, and of course the Task Manager. The system might be slow because the OS does not have the hardware resources it needs. Use the Windows 7 Windows Experience Index to quickly zero in on the hardware component that might be a bottleneck. If you suspect that the processor, hard drive, or memory is a bottleneck, consider using Windows 7 Resource Monitor. If the bottleneck appears to be graphics, the problem might be solved by updating the graphics drivers or by updating Windows. Windows 7 tracks issues that are interfering with performance. To see these warnings, open the Performance Information and Tools window and click Advanced Tools. The Advanced Tools window appears. If Windows knows of performance issues, they are listed at the top of this window. Click an issue to see a recommended solution. Step 5. Try to identify when the slow performance problem began, and then use the Windows 7 Reliability Monitor to find out what changes were made to the system around that time and what other problems occurred. If you don't know when the problem started, skim through the line graph at the top of the Reliability Monitor window and look for drops in the graph. Also look for critical events indicated by a red X. Windows 7 Indexer is responsible for maintaining an index of files and folders on a hard drive to speed up Windows searches. The indexing service has a lower priority and only works when it senses that the hard drive is not being accessed by a service with a higher priority. However, it might still slow down performance. Do the following to find out if this service is causing a performance problem. 1. Find out if the indexing service is currently indexing the system. To do that, click Adjust Indexing option in the left pane of the Performance and Information Tools. The indexing option box appears. If you see indexing speed is reduced due to user activity at the top of the box, wait while indexing is in progress and the status changes to indexing complete. You can now stop the indexing service. To stop the indexing service, open the Service Console, then stop and disable the Windows Search Service as shown here in Figure 4-53. If you notice that performance lows after a system has been up and running without a restart for some time, suspect a memory leak. A memory leak is caused when an application does not properly release memory allocated to it that it no longer needs and continually requests more memory than it needs. To see how much memory an application has allocated to it that is not available to other programs, open the Task Manager and click the Processes tab. In the menu bar, click View, select Columns. Verify that the memory private working sets, handles, and thread columns are checked and click OK. If you observe that the values in these 3 columns increase over time for a particular program, suspect that the program has definitely a memory leak. Note that the Windows 7 Resource Monitor and Performance Monitor give similar information about how memory is used. If you decide a program has a memory leak, try to get an update or patch from the program manufacturer's website. Windows 7 uses a flash drive, or Windows 7 Ready Boost uses a flash drive or secured digital memory card or SD card to boost hard drive performance. The faster flash memory is used as a buffer to speed up hard drive the access time. You see the greatest performance increase by using Ready Boost when you have a slow magnetic hard drive, normally running at less than 7200 RPMs. When you first connect a flash device, Windows will automatically test to see if it qualifies for Ready Boost. To qualify, it must have a capacity of 256 MB to 4 GB with at least 256 MB of free space and run at about 2 megabits per second of throughput. The Windows Aero interface might also be one of the problems that's slowing down your system because it uses memory and computing power. Try disabling it. If performance improves, you can conclude that the hardware is not able to support the Aero interface. At that point, you might want to upgrade memory or upgrade the video card or just leave the Aero interface disabled. Let's now focus on getting rid of programs that refuse to uninstall or give errors when installing. In these cases, you can manually uninstall a program. Doing so often causes problems later, so use the methods discussed in this section only as a last resort after a normal uninstall methods have failed. Most programs written for Windows have an uninstall routine that can be accessed from the Windows 7 Programs and Features window, or an uninstall utility in the All Programs menu. If the uninstall routine is missing or does not work, the next step is to delete the program folders, and of course, the files in it that contain the software. In our example, we'll delete Registry Mechanics software without really using the uninstall routine. To do so, most probably this application can be found in either the C: program files, if it is a non-32-bit application, or in the C program files x86 if it is a 32-bit application. Editing the registry can be very dangerous, so do this with caution and be sure to back it up first. Follow the steps that is highlighted in your textbook on page 204 to 205 in deleting the registry entries. To remove the program from the All Programs menu, right-click it and select Delete from the shortcut menu as being shown in Figure 4-66. If the program has shortcuts on the desktop, delete this as well. Restart the PC and watch for any startup errors about a missing program file. The software might have stored startup entries in the registry, in startup folders, or as a service that is no longer present and causing an error. If you still see an error, use msconfig to find out how the program is set to start. This entry point is called an orphaned entry. You'll then need to delete this startup entry by editing the registry, deleting a shortcut in a startup folder, or disabling a service using the Services console. If a system is giving repeated startup errors, or you have just removed several programs, you might want to search through registry keys where startup process can be located. In the textbook, you can look at Appendix G for a list of all these registry keys and startup folders. As you read through this list of registry keys to search, know that this list is not exhaustive. With experience, you'll learn that the registry is an ever-changing landscape of keys and values. I hope this has been informative for you, and I would like to thank you for viewing.